That's right. Tiny. Oh, look.
So we need
so we've got
a phone.
We've got a clock coming back there. That's good. Pardon me? You see it? Do you need to see it?
Ready in the back. Ready?
Okay, thanks everybody for coming. I think we're going to get started here. I'd like to introduce Chairman Hal Gehman.
Good morning. We will follow the same process that we follow at all of our press conferences. I have a short opening statement. I will ask my colleagues to each make a statement about their part of the investigation. I'll summarize, and then we'll open the floor to questions. I'd like to start off by saying that we are here nearly 7 months since the tragic loss of Columbia, and our efforts, the intent of our report, and all of the many hours that we put into this investigation were done to reflect favorably and to reflect with honor on the efforts of the crew: Rick Husband, Willie McCool, Mike Anderson, Dave Brown, Casey Chawa, Laurel Clark, and Elon Ramon. The lives of these people are very precious to us, and the board considered that a very serious matter, that these brave people thought that what they were doing was important, that it was significant, that it was part of human space exploration, that the things that were going to be learned from this mission were worth the risk that they were taking. And if this board has any impact whatsoever, we felt that their loss of their lives had better make a difference, or both them and us have wasted our time. The board would also like to express its, and I as a chairman would like to express our most profound thanks to a lot of people. I'd like to express my profound thanks to my 12 fellow board members who essentially gave up their lives for 6.5 months to put an awful lot of effort into this report. We essentially work 7 days a week, as you are aware, but most of these people, either one, they put their previous life aside and devoted 100% to this investigation, or two, some of them began leading 2 lives and keeping 2 jobs, and they did the investigation in the daytime and they did their other duties at night. We had about a staff of about 120 people on the investigation team. To them I owe a lot. They worked very, very tirelessly. They did brilliant work. They probably will never get their names in the newspapers or on television, but they did a wonderful job, and we, as a board, are indebted to them. To the hundreds and hundreds of NASA employees who assisted us with this, we are indebted to them. They also made a great contribution. And lastly, as I have mentioned in almost every press conference that I've taken part in, the 25,000 to 30,000 private individuals who helped us, mostly in the area of the debris collection, but in lots of other ways too. We owe a great debt to all of them. As you may be aware, for example, we had over 3,000 unsolicited public inputs, either in the sense of letters or emails to our website. We had all those debris collectors who marched shoulder to shoulder through the state of Texas, picking up that debris, which turned out to be so significant. We had people who contributed photography and videography, all of which contributed to this accident investigation. So we owe a lot of people thanks, and we are the first to acknowledge that we could not have done this by ourselves. Let me say at the outset that this board, and I think I can speak pretty confidently for the 13 members, the other 12 members of the board, this board, it comes away from this experience convinced that NASA is an outstanding organization. It's full of wonderful people who are trying very, very hard to do very unique and very special things. Things that are not done any other place in the world, and for the most part have never been done by mankind before. And we would like to make sure that the American people realize that they have an institution in which they should be very, very proud in the form of NASA. If this board had set out to spend 7 months listing all the good things that NASA does, the report would be thicker than this. Unfortunately, that's not what our task was. And the nature of these investigations causes all of the good work and all of the wonderful things that are accomplished to get lost. And I think it's worth that we take a second and say that we are impressed by the workforce, we're impressed by the people, and we are impressed by what NASA has accomplished. Nevertheless, there's some things they can do better, and it is our intent by the publishing of this report that those things that they need to do better get documented and that we provide the impetus for those changes. Next, I think I speak confidently for the board in which we can state a conclusion that the space shuttle is not inherently unsafe, and that this board was under no pressure to say anything to the contrary. The fact that the International Space Station is up there, the fact that the United States has obligations to finish the International Space Station, and lots of other factors like the sunk costs that are already in the shuttle, etc. I can speak confidently for myself, and I think I can speak confidently for the 12 members. This board was under no pressure to say that the shuttle could continue to be operated. If we thought the shuttle was unsafe, we would have said so. Now, that does not to say there aren't a lot of things they need to improve the safety of the shuttle, but if we thought that this shuttle was just inherently unsafe, we would have said so. However, that doesn't mean that there aren't lots of things that they should do to operate this thing more safely. That's essentially the context of our report. There are some things that need to be done immediately. We have listed those, and we call those return-to-flight items. We'll be glad to talk about them as the time goes on. And then there's a second group of recommendations, which we call continuing to fly. The board feels that there will be so much vigilance and so much zeal and so much attention to detail for the next half dozen flights that anything we say probably is an understatement compared to the energy and the diligence that NASA will naturally put into making the first couple flights safe. The board, however, is concerned that over a period of a year or two, the natural tendency of all bureaucracies, not just NASA, to morph and migrate away from that diligent attitude is of great concern to the board because the history of NASA indicates that they've done it before. Therefore, we have a group of recommendations that are designed to prevent that backsliding or atrophy of energy and zeal, and those are the second group of recommendations that we call continuing to fly. And those are more fundamental and harder to do, but they are just as important, perhaps more important, than the return to fly recommendations. And we are careful not to create any hierarchy of recommendations. We don't have a set of recommendations which are more important than others, and a second group that's less important, and a third group which is third important. We were careful not to make that distinction. You will not find in this report terms like contributing factors or underlying causes. We don't believe in those terms. We believe that these other organizational kinds of recommendations are just as important as the return to fly ones. And then there's a third group of findings, observations, and recommendations that consists of all the things that we observed or noted that we were not particularly pleased with, but didn't have anything directly to do with this accident. But they might contribute to a future accident, and we strongly recommend that NASA pay attention to them too, we once again suggest to our readers of this report that you not mentally categorize these three categories of findings and recommendations in any kind of hierarchical order. To us, the golden nugget, which may prevent the next accident, could be in that third group. And just because it didn't have anything to do with this accident, you should not prioritize them in any other way. We feel very strongly about that. I will stop talking here because I get the last word, and I will ask my colleagues here to say in just a few minutes to talk about their contribution to the report in the section that they're ready to talk about. I would like to have the boards put up, if we could have the board put up the boards over there. That'll happen while we're speaking, and I will then come back, say the last few words, which will be some words about the future, and then we'll open it up to questions. So I'll turn to my colleague here, Dr. John Logston, in Group 4. Go ahead, John.
Thank you, Admiral. The STS-107 accident happened at a particular time in history, but the history part of it, the board decided very quickly after it started its investigation was important. We looked at this as a accident rooted in the history of NASA and the history of the Space Shuttle program. We've given equal weight to the organizational causes that come out of the history of NASA and the program, and you've seen in the report, you'll see in these storyboards the statement of the organizational cause, so I'm not going to repeat that. But as I was added to the board about a month after it started, I was given the mandate to try to trace that history, and we did that, the history of the original decisions that shaped the shuttle program, which are in Chapter 1 of the report, and then the history from Challenger to Columbia, which are in Chapter 5 of the report. I think we can summarize what's there in terms of three main points. One was the budget pressures and workforce pressures. In order to fund other parts of the NASA program, the shuttle program was squeezed during the 90s. Its budget was cut by 40%, its workforce was cut by 40%. That left too little margin for robust operation of the system in our judgment. It was operating too close to too many margins. There was a mischaracterization, maybe even a misunderstanding of what the shuttle was as a mature and reliable system, about as safe as today's technology will provide, is a quote out of a 1995 report. Based on believing that the shuttle was a mature system, NASA turned a lot of its operations over to a single contractor, but more importantly, turned a lot of NASA responsibilities in safety and mission assurance over to that contractor and backed off, did insight rather than oversight of the program. And we believe that was a mistake, and that there needs to be stronger technical oversight by civil servants, by government employees of the program. NASA acted as if you could count on the shuttle to carry out operational missions from 98 on, mainly space station assembly and supply, while not also collecting the engineering information that is associated with its developmental status. We believe that was a mistake. There's a great deal of uncertainty about how long the nation would use the shuttle. And sometimes it was being treated as a going out of business program. Sometimes it's being treated as central to the long-term future. Just in the 90s, the replacement date went from 2006 to 2012 to now 2015, 2020, maybe beyond. It made it very difficult to decide how much to invest in the system, invest in the ground infrastructure, which was deteriorating, and so the whole system was operating in ways that were characterized by uncertainty, by stress, by tension. It's hardly an environment for effective, safe operation of the program, the board concluded. Underpinning all of this was what we've characterized as NASA's human spaceflight culture. That word has been in the news a lot. We provide a definition of culture as the basic values, norms, beliefs, and practices that characterize the functioning of a particular institution. We go into some detail in discussing the particular NASA human spaceflight culture and come to the conclusion that it must be modified for success in the future. Thank you.
Thank you very much. Mr. Hubbard.
Thank you. In 4 simple words, the foam did it. I refer you to the physical cause statement over here. I'm not going to read it, but after months of inquiry, after a lot of analysis, after a series of tests, we concluded that the falling foam impacting the leading edge of the wing was the cause of the breach that ultimately led to the destruction of the orbiter and the loss of the crew. I'll point out one thing about the statement, which is that we did not include the words probably, likely, most probable. All of this exhaustive work that we've done, all the discussion and the testing have led us to the simple statement that the foam was the result, the foam resulted in the breach that led to the loss of the orbiter. My personal involvement has been very deeply engaged with the impact testing. I feel that testing accomplished 3 things. First of all, it provided the experimental evidence that corroborated the lines of analysis, these 5 lines of analysis that Sheila Woodnall will describe in a few minutes. It provided an exclamation point to the directions that the analytical work was pointing to. Second thing is that, of course, it added to the body of knowledge about this reinforced carbon material that turns out to be a lot tougher than anybody thought it was, a lot tougher than the original specification, but unfortunately not tough enough to withstand an impact of this piece of foam at 500 miles an hour. And finally, I think the tests accomplished a third psychological or sociological accomplishment, which is to remove any lingering doubt that indeed this light material could break open the leading edge and could lead to the loss of the orbiter. I think all of this work by our group in establishing the physical cause brings us to the point now where, coupled with the organizational cause, we are able to make a series of recommendations that you'll hear about later. That includes my statement.
Thank you very much. Dr. Woodnall.
Okay, well, many of you have been with us since the beginning, and you've followed in great detail the analysis and the work that has been going on. So as you know, the board conducted an in-depth investigation of the various events that occurred, primarily focusing on those events that occurred during reentry. At the very beginning, we had data from onboard the shuttle that was telemetered to the ground, and this timeline gave very important clues as to what had happened. You also know that in the midst of our investigation, what might be called the flight data recorder, we call it the OEX recorder, was found, which again gave us a wealth of data from onboard sensors that provided information about temperatures and pressures and locations of various things that were going on. We did have these 5 parallel lines of work. We had extensive wind tunnel tests and extensive analysis of the aerodynamics of this vehicle, including its aerodynamic response, its flight controllability. There were detailed thermoanalysis to look at the effects of heat in various parts of the structure, and then the basically burning through or melting through or breaching of various parts of the structure. We had video and photo analysis, much of it taken by the public, which indicated the various events, flashes, debris pieces that occurred during the flight, and these were all pieced together to give a fairly accurate indication of what had happened. The debris was absolutely invaluable. The debris told us a lot about the direction of the flow at various critical areas, about temperatures. Chemical analysis of the debris told us about deposits of various kinds of metals whose melting point we know, that were deposited on the various pieces of debris that were recovered. And in all of that, we were able to derive a very self-consistent picture that, as Scott mentioned, we really have a very high degree of confidence in. I think one of the important things that was demonstrated from the onboard data was that the breach in the leading edge was pre-existing. In other words, we had thermodynamic events that occurred on reentry that occurred at a time when the aerodynamic forces were insignificant. So it leads strong belief to the fact that the breach in the wing was there before reentry occurred. We were able, through these analysis, to document in a timeline the various flight events that occurred. Ultimately, the vehicle, because of structural damage, essentially became uncontrollable. Up to that point, the flight control system had managed to keep the vehicle flying the planned trajectory, but finally it could no longer keep the vehicle flying. And I think the other thing to mention is that at that point the vehicle was so damaged that there would not have been a possibility of successfully continuing the reentry of this vehicle, even if the vehicle had progressed into a region where the heating was reduced. So this was obviously a catastrophic event that determined that the vehicle would be lost. That's basically.
Thank you very much. Mr. Wallace.
I'm going to talk a little bit about the part of the story that fits between the physical and organizational cause statements. Chapter 6 of the report is entitled Decision Making at NASA, and there are sort of 4 stories told in there. A couple of them are fairly familiar. The foam story, you've kind of lived through that with us. Foam was coming off the orbiter from the very first mission. NASA requirements dictated that this not happen, that nothing ever strike the orbiter that could possibly damage it, but it happened on every flight. It actually happened that there was an average of 30 or so dings in the thermal protection tiles on all flights, 7 occasions of bipod ramps falling, and of course a severe bipod ramp failure event just 2 flights before STS-107. I know that's a familiar story, and the question we all asked is the machine was talking, but why was nobody hearing? How were the signals missed? The imaging story, the request for imaging on orbit, the related decision-making, all the emails that you've all seen and printed, that story is laid out in great detail in Chapter 6 as well, with also with information gained from other sources, interviews, and various records. The third story in there to actually come second is the schedule pressure story, which has not been quite as extensively discussed during the course of the investigation. And I would say that the schedule pressure story is laid out in great detail in the report. I think it's fair to say that opinions can easily differ. They have among us on the importance of this issue, and it's not easily quantifiable. There are a lot of subtleties in the schedule pressure. We're not talking about fist banging on tables, we've got to launch on this date, but rather more subtle pressures and influences. And I would encourage you all to read that part of the report carefully and decide if, I think you'll conclude that it's thorough and probably that it's fair, and I like the entire report. We hope that this entire story is thorough, that it's fair, and that it really helps the human spaceflight program in the long term. The fourth story in Chapter 6 is about the repair and rescue possibilities. We asked NASA to do a study on this, which we think they did very, very forthrightly and thoroughly. I think there are 2 reasons to look at that. One is to simply know if it was possible, or what were the probabilities of being able to effect a repair or a rescue mission. And the other is to analyze how it affected the thinking on the mission, whether that possibility, if it had been better understood, might have altered some of the decision making during the mission. From Chapter 6 we go into Chapters 7 and 8, which discuss, in context of organizational theory, more of the the relationship of this decision-making and studied in the context of other high reliability organizations, other organizations which do very high-risk work and quite successfully, naval reactors, sub-safe program, different programs are analyzed in there, and then the whole, the entire accident and also the Challenger accident are really evaluated in a thorough historical context in Chapter 8. I think it's important, although it's a daunting task to read this report from one end to the other, and then you come away with the entire story. Thank you.
Okay, General Barry, thank you.
Thank you, Admiral. My comments will be on safety culture. Now, as the Admiral has said, we've met some fantastic and outstanding NASA employees all the way through. If you talk about safety, industrial safety is world-renowned. However, it's our view that the broken safety culture resides in the human spaceflight. Now, I refer to our organizational chart. We talked about the cause, but clearly there is still evidence of a silent safety program with echoes of Challenger. And here's the Challenger report. NASA had conflicting goals of cost, schedule, and safety, and unfortunately safety lost out in a lot of areas to the mandates of operational requirements. So what we went through in our analysis is trying to figure out how we can fix the culture, and it's not an easy task. In order to do that, you have to do some organizational changes, and clearly we have made some of those recommendations in this report. But the second part of that recipe is leadership, and that is where NASA has to do its role. We can only provide recommendations on some of the changes, but the leadership is clearly key to that. The other thing I want to mention is that we had some concerns about safety regarding independence, and you'll see that as one of the key recommendations when you get to the organizational part. There was and has been evident a lack of integrated safety functions, but more importantly, a lack of integration within the safety within the Space Shuttle program itself. We have evidence and interviews, and our research has shown that the integration office was not truly an integration office, and that compounded the safety culture problems of trying to get one story for the whole program. There also is barriers to communication, and some of them that are cited are lack of shuttle ineffective information systems, databases, and finally, going back to the silent safety program issue, we found evidence of silent safety in not only the program, the flight readiness review, the debris assessment team, and the mission management team. So, ladies and gentlemen, it's still there. That concludes my remarks, sir.
Thank you very much. Admiral Turcotte.
Good morning. I'd like to talk to a little bit today to you about my experience, primarily my focus in the investigation, and my good friend Brigadier General Dwayne Deal, who is not here today, who's on his way from Houston to this location. The two of us spent the majority of our time getting very close to the people that maintained the orbiter and also built the various other pieces that machinered the external tank and the solid rocket booster. That was primarily our focus. And in Chapter 10, I'm going to talk to you a little bit today about some other significant observations that we found in the course of the investigation. We naturally went through the maintenance records of Columbia 100%. We went through all of the existing maintenance records all the way back to day one. We went back through every maintenance period that it had, and then every single major gripe that we could focus in on that had anything to do with TPS or the thermal protection system. Then we looked at a random sampling of all of the other orbiters and looked at how they did maintenance, whether it was a NASA employee or a contractor employee, it didn't matter. We went through the depth and breadth of this. So I'd like to throw out, in our time on the shop floor, those are good people. The people that are down there working, they're working their hearts out. They've got the right idea, the right mindset. They're trying to do the best they can. These observations I'm going to show out today are indicative of something that you could walk into a lot of organizations, but in particular, we found some things that are different from the aircraft industry standard or the military industry standard, and those are what I'd like to just throw out. First off is the QA program. QA program, they went through a series of downsizing, took their inspection points and made them a number of 85. They left them pretty stagnant. Well, as you know, this is an aging orbiter. If you look inside that airplane, the airplane that I flew is 25 some odd years ago. It's very similar to that. The problems that we had with corrosion are ongoing. The problems as this airframe changed, also the inspection points will change. And that's an industry standard. As an aircraft ages, the maintenance changes, your inspection points changes. We found that to be lacking in the QA program. We found out in the corrosion program, a lot of hard things to do there. There's, for example, the capsule. There are some points that will, short of taking the orbiter apart, we'll never be able to get to look at. So NASA's got to figure out some ways to get in there and look at those and find out the true age of the orbiter. We looked at a lot of the test equipment that was used in industry today. A lot of the equipment that is used on that program is 22 years old. It's frozen in time. It's just as it was when that thing was built. There's a lot of good test equipment out there that is in use in the industry, and we've made several recommendations to incorporate that. There's some other anomalies that we saw looking at. You've heard of the famous hold-down cable or hold-down bolt cable problem. Just the way that problem was treated, and if you apply the technical wiring and the engineering to the way that problem was treated, does not meet industry standards. Classification of Fadh. My good friend General Deal dealt a lot with this. If you look at the way an aircraft on the flight line versus the way an aircraft in a factory are treated, they are two different entities. With the space shuttle, it's pretty hard to tell the difference because you're looking at one hangar, you're doing a major maintenance where you have to open this thing up to the world and do some very major repairs. Then you look right next to it, you have somebody working in an operational mode where the rules are different. So we're making a recommendation that they standardize the classification of Fadh across the board for both of those. Generally, all in all, I want to refer back to my first statement, what I said. The people on the shop floors putting this orbiter together and maintaining it have the best heart and souls. They are absolutely wonderful people, and it's been a pleasure working with them. And I just want to leave that final thought to you, that on the shop floor, they're looking forward to getting this thing. And as the cry from one of the supervisors when I left, he says, "Sir, we hope you find it, you fix it, and you fly it." And with that, I'd like to conclude my remarks.
Thank you very much, colleagues. I'll wrap up here, and we'll get to the questions. As we indicated when we started this investigation 6.5 months ago, this board has 5 constituencies. And at 10 o'clock this morning, Eastern Daylight Time, our report was delivered personally to all 5 constituencies simultaneously. 3 board members who are not here are in Houston, and they personally delivered the same report that you're receiving here, along with copies of the report to our 2 constituencies in Houston. That is, the astronauts, the astronaut corps, and the families of the astronauts who lost their lives in this accident. Meanwhile, here in Washington at 10 o'clock this morning, the report was delivered to representatives from the White House, the Congress, and to the administrator of NASA. As a matter of fact, 3 of the board members, the reason they're not here is because they're down in Houston doing that, and they will be joining us. They're flying back this afternoon. So I'll just close by saying that the board is quite convinced that most accident investigations do not go as far as we did, in that most accident investigations find the widget that broke, they find the person in the cause chain closest to the widget that broke, require that the widget be redesigned or replaced and the person fired or retrained, and then call it a day. And they do not go far enough to find out why did this happen. And the failure of that is that you really haven't fixed the problem which caused the problem. You really are setting yourself up for a repeat if you have other organizational or systemic problems. And because it took the board a considerable amount of time to convince itself that the foam did it, we had ample time to look into these other causal categories, and we are quite convinced that these organizational matters are just as important as the foam. Our recommendations, which I will now ask that the boards, they're very good, or they're ahead of me. Our recommendations could be roughly organized along the following kind of logical lines. What we said is what we would like to do in the sense of our recommendations is we would like to break up or loosen the close coupling between debris hitting the orbiter and losing the lives of astronauts. In order to do that, you have to take several steps, not one step, but several steps. The first step you have to take is you have to understand and reduce the amount of debris that the stack sheds, whether it be foam or ice or whatever. The second step is you have to toughen the orbiter so that it can indeed fly through a cloud of debris without doing itself some damage. The third step is you have to provide a system by which the orbiter can be inspected and repaired in case it did get a little ding or something like that, and so that it does not become a life-threatening event. And the fourth step is you have to do something to enhance the crew's survivability. Now, we addressed the first three completely in our report. The fourth step, enhancing the crew survivability, we've decided to arbitrarily leave that up to NASA, and they have done some work in that areas. We organized our recommendations into three categories, as I indicated before: short-term fixes, which you might call return to flight; mid-term, by mid-term we mean something like 2 to 10 or 2 to 15 years, or what I call continuing to fly recommendations; and then a long-term, and there the board has written editorial comments about what the nation should do about human space flight, about replacing the shuttle as our human-carrying vehicle, and we have editorialized about what we should do long-term. Therefore, the intent of this report is that this report, in our words here, should now be the basis for what we hope will be a very vigorous public policy debate about what do we do now? How soon do we replace the shuttle? What is the United States' vision for human spaceflight? And once you answer the question, what is our vision, you have to then answer the next question, are you willing to resource that vision? Because this stuff is not cheap. And what should be the balance between human space travel and robotic space travel? And a number of other public policy issues which are not the purview of this board to answer. These questions are the purview of the government of the United States and its agencies. So we aren't ducking anything here. What we have done is we have established all the facts. We have characterized NASA and the space flight program in a way that's not been done in this depth before. We've characterized the risk. We've characterized their strengths and their weaknesses. And now we turn this report over to the people in the United States who establish public policy, who is not us. So with that, I would then conclude, and I will turn it over to Ms. Brown, who will orchestrate some questions.
I'd like to take questions for about half an hour. The way I'd like to do that is to try to do it geographically, just so our guys with the microphones can maximize their maneuverability. So if we can take questions in the right over here first. Right, Marcia?
Marcia Dunn, Associated Press for the Admiral. On the organizational managerial problems, I was struck by, in reference to the STS-113 Flight Readiness Review, a reference to the sleight of hand in calculating the foam loss and making it seem not as bad as it was. And also, during the Columbia flight, Linda Ham's comments that the rationale was lousy to keep flying, and it still is. This sounds more than overconfident. It almost sounds negligent, and could you address that? And why wouldn't you want these kinds of problems fixed before return to flight?
The role of establishing judgments on personal performance is not one that we set out to do. We have said since the first week that we'll put the facts in the report, and we'll let the proper authorities determine whether or not that is a matter of performance or not. To us, statements like that are data, and we use them to determine how the system operates, not how the individuals operate. Steve Wallace, you want to follow up on that?
Well, and I think they are both certainly being corrected. The sleight of hand refers to a calculation about falling bipod ramps, which sort of used the fact that there were two bipod ramps. One had never ever fallen off over there, the right-hand one by the locks line, which probably aerodynamic reasons or whatever. So we thought that the probability calculation didn't, how should we say, if we're accounting, I'd say it wasn't done according to generally accepted accounting principles. An engineer would say something roughly equivalent to that. And the lousy then, lousy now, and the report, of course, includes the view graph which details the decision-making on launching 113. I think that's all in the context of the greater story of sort of the normalization of foam. And then 107 is launched subsequently, and the issue is no longer even on the table. So those are, as the Admiral said, that's data which forms a part of the larger story.
And John, very quickly, John.
Yes, sir. Just to answer a question about the recommendation, if you look down on the bottom, organization, one is RTF, and that is to develop a plan to get a technical independent review capability, to develop an independent safety, and to develop a better integration. So that is a return to flight requirement that we're asking for organization.
Okay, thank you.
Okay, thanks. Thank you. Irene? Thanks.
Irene Klotz with Discovery News. I think this is probably for General Barry. On the Technical Engineering Authority, could you explain a little bit more what you would envision accomplishing by stripping NASA management from operational, or separating the operational decision-making about just shuttle processing from, like, the technical requirements of the shuttle, and how you would see that working in a real-time scenario?
Well, the recommendation you're referring to, as Steve has just pointed out to me, establish an independent technical engineering authority that is responsible for technical requirements and all waivers to them, and will build a disciplined, systematic approach. What that really means is we're trying to separate the requirements from the program. If the program is competing cost and schedule, and they still own the requirements and the waiver authority, you will sometimes find that you will compromise the waiver and the safety for cost and schedule. So what we found by looking at best business practices, particularly SubSafe in the Navy and the aerospace organization, is that by separating this out, you put a check and balance in the system that clearly allows the system to work in a more fair basis. And you don't put safety and waiver and technical requirements at risk with the same organization that is compelled to work schedule and the schedule pressures and the ability to launch operationally.
Okay. In the blue, Richard?
Thanks, Steve.
Richard Harris from National Public Radio. You focus a great deal on culture and the need for NASA to change culture, but how can an organization like that change culture, particularly when you look back at Challenger and you see a lot of the things that were said pre-Challenger exist today? Is it possible to change culture?
Well, I'm going to repeat what General Barry said in his introductory remarks. We thought a lot about this. We thought long and hard about this. We discussed it for hours and hours, and we have come to the conclusion that there are two steps into changing the culture, part of the culture that need to be changed. Now, first of all, keep in mind there's good culture and there's bad culture. You know, you can have a culture of safety, and you can have a culture of openness, and you can have a culture of honesty and all that kind of stuff. So, you know, culture is not a bad word. As John Logston indicated when he defined culture, culture is the way that the organization habitually acts absent rules. In other words, this is the way that people kind of intuitively act, regardless of what the rules say. We think that there are two steps to changing, to weeding out the bad parts of the culture and changing the culture that needs to be changes. One is you can take some organizational steps that help a little bit, but we believe that you can change a bad organization by reorganizing it, but you cannot change bad culture by reorganization. It takes both reorganization and leadership. The leadership, not just the administrator, all levels of leadership, are going to have to actively drive the bad cultural traits out of the organization. And it's something they're going to have to buy into personally. They're going to have to accept it in their gut, and in their daily reactions, they're going to have to look for these traits that we have carefully enumerated in our report, like stifling communications and stomping on engineers and things like that, and they're going to have to drive it out. And it is not simple, and that is why we did not make it a return-to-flight issue, because we know it can't be done between now and the next flight. It'll take a long time.
Okay, let's go to the second row. Kathy?
Kathy Sawyer, The Washington Post. Admiral Gehman, I believe it's Dr. Logston who has called NASA culture a fortress mentality. Am I right? No. Somebody has. Anyway, given the loss of the Cold War impetus that you cite in the report, and given that the public and the Congress seem to have indicated a desire for a space flight program but not a great willingness to pay more for it, what are your comments on continuing to fly under those very same circumstances?
You're edging up toward the answer to the public policy debate that we're challenging the government of the United States to have. I think that in the sections that John referred to, chapters 1 and chapter 5 of the report, in which we established a historical context of how we got to where we are, it paints the picture that there's two sides to this issue. That is, one side is that NASA over the years has over-marketed, over-promised, and underestimated what these things cost. And therefore, we've gotten ourselves in a position to where we have programs now that we own that are extraordinarily expensive. And they never, ever have achieved either the goals or the cost goals that they set for themselves. But that doesn't mean they can't be done. That doesn't mean that space travel can't be done relatively safely. So it seems to me that the answer to your question is perhaps some renewed honesty on both sides of the equation here, in which NASA doesn't overmarket programs in an effort to get program, and that also the branches of our government don't require unrealistic goals that can't be achieved. And I believe that's laid out in our report. John, you want to say something about that?
Well, I think the only thing I'd add to that is that the people who provide the resources for human spaceflight, the White House, the OMB, the Congressional Authorization and Appropriations Committees, all certainly believe that they're providing adequate resources. Nobody is trying to squeeze the program below an adequate level. On the other hand, human spaceflight has had to compete within NASA. Well, the shuttle has had to compete with the cost of the station. Human spaceflight has had to compete with robotic spaceflight. NASA's activities have had to compete with other science and technology areas. And the country has been kind of ambivalent about how serious it is about its long-term space program, and has done it, I think in our judgment, at a budget level not adequate to have a robust program. You can't draw a causal line that says budget constraints caused accident. We don't go there. We say it created an environment in which the things that could cause accidents could emerge. It's a multi-layer kind of causality that we're talking about.
And in our report, we try and establish in Chapter 9, in kind of the editorial section of our report, we suggest a way out of this dilemma. And without prescribing what the next program should look like or what the next vehicle should look like, we suggest that what really needs to happen is that we need to decide as a nation what it is we want to do. We shouldn't start off by trying to design the next vehicle. That's a trap. And it's a trap we've fallen into 3 or 4 times in the last 15 years. We should decide what it is we want to do, and the board suggests that what it is we want to do is to get humans in and out of low Earth orbit routinely and safely. That's what it is we want to do. Not add a whole lot of bells and whistles to this thing like single stage to orbit and build it out of the famous unobtainium material that floats around here, and get on then with a program to support an agreed concept of operations or whatever it is we want to do. In other words, rein in our appetite, properly fund the program, and develop a program that is executable within what the nation wants to pay for it. It's in our report how to do this. Now, we didn't design the vehicle for the nation, but we told them how to get out of this dilemma.
Okay, in the third row, right behind Kathy.
Admiral Gehman, we have here detailed finding and detailed recommendation. If you have to tell the American people briefly what caused that accident that day, what are you going to say in a few words?
In a few words, I would say there were 2 causes to the accident. The first cause was the foam that came off and hit the reinforced carbon-carbon. The second was the loss within NASA of its system of checks and balances.
Okay. Okay, right there.
Al Milliken, affiliated with Washington Independent Writers and Solution Radio. This week, my daughter Amy is at the NASA Space Camp in Huntsville, Alabama. Would anyone have any special words to help a child and student like her to help her understand what happened?
Dr. Widnall, would you like to take that on? Well, the reason I pick on Dr. Widnall is because she deals with students, and she has actually lectured us before on what the students expect. And so, Dr. Widnall, I'll ask you to answer that.
Well, I think it is the case that space and the idea of space is really a great motivator for young people. I don't think there's any question about that. And I think I certainly view one of my jobs as an educator is to take that basic motivation and turn it into what I would view as responsible engineering, recognizing that the passion that we have for spaceflight needs to be realized in a system that can responsibly execute these programs. So that may be a big mouthful for your daughter, but that's my view on the whole issue.
Could I add
Sure, absolutely. Dr. Logston, another educator.
If you look at the backgrounds of the board members, the 13 of us, 9 of the 13 had very little or no involvement with NASA or with spaceflight before they became members of the board. All 13 in the report are unanimous in the importance of continuing human spaceflight. None of us have come to the conclusion that it is not worth the risk and not worth the money. And I think that message is one of the positive messages that ought to come out of this report.
Okay.
Thank you very much.
In the second row, the yellow tie, Ralph.
Thank you. It's Ralph Artabadian, Los Angeles Times. I have a question about 2 of your return-to-flight recommendations that involve the thermal protection system. One of them calls on NASA to eliminate all external foam debris, and the second asks NASA to initiate a program to increase the ability of the orbiter to sustain debris hits. As I read this carefully, both of those look like they allow a fair amount of wiggle room for the agency because it asks only that you initiate an aggressive program. Does that mean that before the orbiters resume flights that those improvements should be in place, or only that NASA begin an action program to do so?
the recommendations, we do, our study, after months and months of this, leads us to believe that it's unreasonable to require as a return-to-flight item that they eliminate all debris shedding from the launch stack. There will always be some ice, and the application of the insulating foam on the external tank is really a very difficult process to do. And so that recommendation aims at the problem that we found that they are not aggressively trying to understand the foam, that they aren't. We found, you remember Doug Oshrob's famous experiment in his kitchen where he discovered some things that how the foam acts that were contrary to what was published in some NASA technical manuals, and et cetera, et cetera. So that is aimed at a continuing nonstop program at understanding how the foam acts with a intent of eliminating debris shedding eventually. But we didn't think that saying that you got to stop all shedding before you can launch again is reasonable, because that's not how the machine operates. So it is initiate a program with the intent of understanding what causes foam to come off with the ultimate goal of eliminating it.
Does that apply also to the RCC?
Yes.
Just initiate.
That's correct.
Okay.
Both of those get at our problem. One of our problem with NASA engineers is that because the money has all dried up in research development, they aren't even trying to find out what the materials do, and so that's what that recommendation's at.
Okay.
Yeah. Okay. Very quickly, Steve.
I think you have to take it all in the context. I mean, there's an extensive set of recommendations on on-orbit repair. One point that is a flat return to flight, not initial return to flight, on-orbit repair. And, so of course the board is working to eliminate the source of the debris, improve the ability to tolerate a strike should it happen. And of course the most critical thing is perhaps the falling bipod, which in NASA, you will never see another bipod ramp on this vehicle. There's no left bipod ramp. They are there's a lot of work in progress that we're well aware of and have been following in addition to what's simply on those recommendations. Okay.
Okay, Tracy.
Tracy Watson, USA Today. I guess for General Barry and anyone else who cares to weigh in, I'm wondering if you had an emotional reaction to this report. It's a pretty powerful document. Did what you found as you plowed through this institution make you angry or sad?
Well, that's a tough question. I mean, after 7.5 months of looking at this thing, you can't help but get emotionally connected to not only the people but the organization. And as Steve Turcotte mentioned, you really do find an agency that is just full of outstanding, superior, well-motivated individuals. But anytime you deal with an agency in crisis, you really find out what the guts of the organization is made up of. And one of the things that we want to make sure that we leave here, and as the Admiral said, is the legacy in honoring the crew that lost their lives. So there's not one day that didn't go by that we didn't pass the photograph of the crew right by the entry to any of our organizations. And if you have seen any of their recent, it was last night or a couple of nights ago on the History Channel, they had Failure is Not an Option. We as a board went to the museum, Aerospace Museum, and saw the International Space Station movie. All those combined that brought home the reality of the significance of what we were trying to do in being able to provide the tools, the recommendations, and certainly the ability that NASA can get back to fly and we can get human space flight back in orbit. You cannot do that without getting emotionally connected.
Dr. Widnall.
I think the board set a rather high target for itself. Certainly from my point of view, I wanted to make sure that we were not just the second report on a shelf to be joined by a third report relating to an accident caused by the same factors that we had become aware of during our study. So I think we tried to be more comprehensive.
Okay, thank you very much.
Okay, can you take, in the white shirt?
He's already asked enough questions.
That's John Schwartz from the New York Times. Admiral, or whoever wants to join in on this one, the folks at NASA have been preparing themselves for a big shock over the last few months. and Administrator O'Keefe has gone so far as to say the report's going to be ugly. You've put it on the table now. Is it ugly?
I would not characterize it as ugly, certainly. I would say, however, that the board was well aware that in the world in which NASA and all other big bureaucracies operate, that if you really want to make them change something, sometimes you have to be rather dramatic with your reasons for making them change. And so we tried to write a complete report. It's possible that we repeated ourselves a couple times in there, but we did that for emphasis because we know how hard it is for big organizations to change. Most all of us on this board have experience, either in the past or present, with running big organizations, and we know how hard it is to get organizations to change. So we added some things in there for emphasis. We repeated some things for emphasis, and someone might construe that as ugly, but I don't construe it as ugly. I view this report as clinical and technical, and not unnecessarily ugly.
Okay, I'm going to move over here to the left in the front row here, Bob.
Hi, Bob Hager with NBC. You said that the debate over how soon we replace the shuttle is a matter left to the nation of the Congress. But as on the question of how long this shuttle can fly, it sounds like you're saying quite a while if you're talking about recertification by 2010 and talking about the midterm maybe 15 years out or so. That sounds like well into the next decade if these changes are made.
We didn't put a year on it, but we did make recommendations along the lines that you indicated, that if you intend to fly this thing beyond the short term, if you intend to fly it for 10 or 15 more years, there are a large number of things that need to be done in order to do that safely. We didn't put a time certain on it. We did editorialize, however. It's not a recommendation, but it's in our comment section in Chapter 9 that we believe that another vehicle, either a complement or a replacement, is a very, very high priority. Matter of fact, we criticize the United States for finding ourselves in a position where we are right now, where we don't even have a vehicle on the drawing boards, and we are critical of that process. So we do have some sense of urgency that another human-carrying vehicle needs to come along fairly quickly. But no, we didn't put a time limit on how long we think the shuttle will last. We do believe it can be operated in the midterm if we make the changes that we said.
Let me add just one quick thought to that. I mean, we say if the country intends to fly the shuttle past 2010, it needs to go through recertification. It's possible it will not pass the recertification.
Or that'll be too expensive.
So I think we come out kind of agnostic on how long it should fly, depending on what happens when you take the close look at it.
And by the way, this is not the board not taking a position. That is our position. I mean, we spent hours on this, is exactly how we should characterize our position on how long the United States should use this shuttle. And our position is that, A, we are very disappointed that there's not a replacement vehicle, at least on the drawing boards. And B, if you're going to fly it in the midterm, you got to change your management scheme. And if you're going to fly it beyond 2010, you need to requalify it as a system or recertify it. So this is not a non-position. This is a strong position, and might be a very expensive one.
Okay, on the corner here on the left, Mark Carreau.
Mark Carreau from the Houston Chronicle. My question has to do with the desired chain of command for safety. I guess I'm a little confused from reading the report exactly how this technical engineering authority would fit into the scheme. Would this be like a separate entity with its own administrator, or would it be under the umbrella of NASA with some authority or chain of command that you could flesh out a little bit?
Let me give you an example.
Mr. Turcotte, try a shot at this.
Let me give you an example from the aspect of the Navy and the Air Force and the way we run our programs. I'll give you an example of a squadron commander or a commander of a ship wants to make a modification or has a failing part that's in some way failing. He does not have the decisional authority as that entity to do that. He has to go to an engineering authority, commonly referred to as our system commands, separate authority that owns the technical requirements, submits a request, and if, in fact, the technical authority says it's good to go, then you can either fly that aircraft or steam that ship or that reactor or that part or dive that submarine or jump out of that airplane or whatever. Unlike in NASA, the decisional authority for that waiver resided with the program. So our goal here is to have the program operate, maintain, fly the shuttle, but have the technical requirements reside separately, so that the program has to go to another entity and is not deciding its own margins to operate.
Mr. Wallace?
Well, just to clarify, I think one of your questions, Mark, was not separate from NASA. Not separate. Separate from the program that has the schedule, that we got to get this built by this date, separate from the schedule. And I think that the related recommendation also that follows that one is the independent safety program. Again, not separate from NASA, but the safety organizations that we found to be sometimes in sort of an undecipherable matrix, and we wanted a much more straight line authority on that.
Okay, in the second row on the end here.
Thanks. Jeremy Magnier, Chicago Tribune. The sixth chapter, I think, has a pretty strong indictment of the scheduling pressures that were put on the program. I think at one point you say that the reaction, as a result, the reaction to the foam strikes focused, probably as a result, focused less on safety than on keeping to schedule. And the fact is that, as you say, the schedule came right from the top, from Sean O'Keefe. I mean, how big a factor was that, and how would you describe the relationship between those scheduling pressures and the decisions that were made about the foam?
I think it's impossible to quantify it. We tried to tell that story very thoroughly. I think you can see in there. It's important to read the scheduling part of that chapter and then read what immediately follows it, which is the imaging request story. And it's in a logical sequence there because you see two things. You see a concern about how this might affect the next mission, 114. And then I think you also see in there also a suggestion that, well, there's nothing we can do about this on this flight. And so it gets to be a turnaround issue, and then there's a discussion about the flight readiness review criteria on the prior flight 113. So I think you read that entire story together, read the imaging story which follows it, and you can't put a number on this, but you can get a sense for the schedule pressure.
Okay. Let's move down that row. Deborah, in the black.
Hi, I'm Deborah Zabarenko. I work for Reuters. We've talked a lot today, and you certainly discussed in your report a lot about NASA's culture. Several of you have stressed the point that when you deal with folks on the manufacturing floor, when you deal with other personnel at NASA, there's no lack of dedication, there's no lack of commitment to the program. But it seems to me that culture is people. So at what level do you think NASA should attack this cultural problem? If it's not at the lowest level, and we don't know if it's at the highest level, where should they be looking?
Well, let me start off by trying to answer that, and then I'll ask my board members to correct me if I get it wrong. First of all, we in our report did not exactly equate culture to people as you did in your question. We equated culture as how people behave, and you can't change people's philosophies and attitudes, but you can change people's behaviors, and it's up to leadership at all levels to do that. Now, I have some personal experience with this, and many of our board members do too, in which a new boss comes in and He changes the way the organization operates or talks or thinks or its attitudes and things like that. And that's really what needs to happen, is that they have to believe it in their gut, and they have to say it every single day. And every time they deal with subordinates, every time there's any kind of a give and take going on or anything like that, they have to reinforce the kind of traits, attributes, and characteristics that they want their organization to follow. I mean, I'll give you a case in point. If you say that safety is the most important trait and characteristic of this organization, but then you require a person who's in charge of some program to come and travel to your office every month and report on how the schedule's coming, well, you're saying one thing and you're sending another message. So that's why we say that this is a difficult, challenging job. It's got to be done by the top-level leadership, not just the administrator. He can't do it by himself, but at all levels of leadership. But we view it to be extraordinarily important. Scott, did you want to jump in on this, or nope? Nope. Okay. All right.
Okay, Frank.
Let us. All right. We'll go ahead to the next question.
Frank Mooring with Aviation Week and Space Technology for Mr. Wallace. On the scheduling issue, the scheduling pressure came from the demands of the International Space Station program. The space station's still up there and occupied, and I think maybe even exerting some pressure today on the return to flight. How do your recommendations mitigate that pressure, particularly in the near term?
Well, I think we've made a strong story about that the source of pressure, which you specifically identified, which is the Node 2 complete, and even you might even argue that, gee, what's wrong with a screensaver? But there's I guess a line between what's morale building and encouraging the workforce and what actually then becomes another subtle form of pressure. I mean, I think that the entire tragedy here is a massive stop and rethink point, a turning point for NASA, as it says in the board statement, which I think the whole schedule gets kind of zero based at this point.
I think I'd like to add that the ISS does add schedule pressure, as it should. And, oh, by the way, schedules are not bad. They're good management tools. There's nothing wrong with using schedules as a good management tool. Everybody does it. I have been accused by this board of exerting schedule pressure on them.
Yes, sir.
3:30 in the morning.
But our concern is that various places in the organization are denying that there was any schedule pressure. And other places in the organization were screaming that there's schedule pressure. And it's that disconnect is what we're concerned about. Of course there's schedule pressure with the ISS because the crew's got to go up and the crew's got to go down, and supplies got to go up, and every once in a while the ISS has got to be boosted, et cetera, et cetera, et cetera. But we found that the use of schedule pressure as a positive instrument was being misapplied, and it was not turning into a positive reinforcing instrument.
Okay. Mike, go ahead.
Mike Cabbage with the Orlando Sentinel for Admiral Gehman. I wanted to ask you a question about your thermal protection system return to flight recommendations. When you issued your preliminary recommendations, it appeared to me that it called for, before returning to flight, that you have a TPS inspection and repair capability. And as I look at the recommendations and the way that they're written now, it does not appear that it is a return to flight requirement. And I wanted to sort of clarify that and ask you also, how important is it to you that you do have a TPS repair capability in place before you fly again, given the fact that if you have an engine out on the way to the station or you undock, another crew could find itself in the same sort of predicament that Columbia was in?
Okay, I think it's just a misunderstanding. Recommendation 6.4.1 contains 4 provisions, all of which are return to flight.
So developing an RCC repair is a prerequisite of return to flight.
That is correct, exactly as we issued it. It's just we put RTF after the recommendation. We only put it once in there, and there are 4 provisions to it. But yes, we are sticking by our interim recommendation that you must develop before return to flight and on orbit inspection and repair for both the TPS and the RCC. Yep.
Okay, Todd?
Todd Halverson of Florida Today for the Admiral, or whoever would like to take it. You note in the report that managerial and organizational problems echo back to Challenger, that the same types of problems are still there and there are many parallels. And you also note that NASA has a history of not fixing that type of problem, of getting back to business as usual after a short period of diligence after an accident. What do you think will happen if NASA neglects to or fails to fix their institutional problems as they exist today?
Well, NASA is an independent agency responsible to the Congress and to the administration. There is no cabinet officer overseeing NASA. Therefore, the enforcement mechanism must come from those two branches of government. So we are putting a little bit of a burden here on both the Congress, the oversight committees, and on the White House to put in some kind of a follow-on mechanism to make sure that these changes are implemented. And there's lots of ways to do it. You can establish review panels and blue ribbon panels and annual reports and all that kind of good stuff, all of which we think should be done. But I don't believe that we should just trust NASA to do this. I think there needs to be some follow-up.
Okay, Seth?
Seth Borenstein, Knight Ridder Newspapers. You talk about the cultural changes and the need for leadership to do that. Does that imply that there's a need for new leadership? And what's the role? The Rogers Commission talked a lot about astronaut leadership. We also have there's also a question of engineering skills at the top leadership level. How much of a change needs to be put on the very top leadership of NASA, especially when you say they're not the ones that they say they didn't see any schedule pressures?
We don't have any opinion one way or another about the individuals at the top leadership of NASA. We've gotten nothing but cooperation from NASA. We've heard all the right words from NASA leadership, but we as a board set a long time ago a internal rule that we were not going to try and chase the rabbit here. And that is, as NASA changes and as they do things, we aren't going to be continuously trying to comment on the things that they've said or done or implemented. So, as we like to say, T equals 0. T equals 0 is 1 February for us. As we are reporting on this event as of the date and time of the crash. I have no reason to believe that there's anything in this report that cannot be implemented by the leadership of NASA if they choose to do so. So I think it's more of a philosophical thing than a competency thing.
Okay, Bill.
Bill Harwood, CBS News, and that segues right into the question that I had, and I'd like for you and maybe Mr. Wallace to answer this, and that is, yes, they can do these things. If they do you guys believe in your heart of hearts that NASA will, in fact, be able to affect these kind of changes? Because several places in the report you point out we have no confidence that other corrective actions will improve this, and changes we recommend will be difficult to accomplish, and they'll be internally resisted by NASA. So I'm wanting a personal opinion from both of you. Will they do these things?
We'll let Mr. Wallace go first.
Yeah, right. Then I'll be. My confidence is fairly high. I don't see that we draw. I mentally sort of can't draw a sharp line between some of the organizational changes and some of the cultural changes. I think they go hand in hand. So if an empowered independent organization that owns the technical qualifications and requirements and the waiver authority, coupled with a really empowered safety organization, and we're talking about organizations which all have a final signature on the certificate of flight readiness. I think the evolution of that organization, which then sort of takes the authority away to some extent from the program that's really trying to meet the schedule and build the thing. So I also think that the fact that this is the second loss, and we've evaluated the accident in the historical context, including a very point-by-point comparison to Challenger. A lesson we learned here is we gotta. It didn't get fixed last time. There has to be a different approach now, and I really think there will be.
I think it's fair. I think it's fair, even though we didn't write this down in our report, to say that we find two problems in this area. The first problem is that NASA management over the years, due to external influences as well as internal influences, has morphed its management structure to where so much authority and power and so much responsibility has been put into one vertical chain, the program manager, and that they've lost all their checks and balances and independent research and independent engineering and all that kind of stuff. That's one problem. The second problem is NASA's been told this 10 times. So they're guilty of two things. And we put that in there for emphasis to get at, in order to satisfy ourselves that we have enough emphasis in here to satisfy ourselves that they will change, and that the system will make them change, and that they will buy into it. So yes, we've added some of those things for emphasis, as I said in my opening remarks. Okay.
Okay, one more question right here.
Dan Billow from WESH TV. Admiral Gehman, would you talk a little bit about the rescue scenario? Do you believe that with normal and reasonable procedures that the MMT should have arrived at that EVA on Flight Day 5?
I would separate in my mind your question whether or not an EVA to inspect the wing was prudent or not from the rescue thing. I consider them to be two different things. From my understanding, to go out and take a walk and lean over the wing to see if you had a hole in the RCC is not very risky. It's well within the capability of the training of the astronauts. If they were really curious and really had a lot of engineering curiosity, they were really suspicious, and if they were really concerned about pinning down everything that might be wrong with the orbiter, they would have attempted, first of all, to get some imagery. And if the imagery was inconclusive, which it may have been, by the way, they may have got the imagery and then it proved nothing. I consider that going out and taking a look at the wing to be relatively a prudent thing to do. The rescue thing, you used the word rescue in your question, that's a whole other enterprise, and the risk goes way up when you do that. And I wouldn't want to comment on whether or not it was something that they would have really, no kidding, chosen to do. The only thing we do know, and everybody has agreed upon this, the Congress, the President, the Administrator of NASA, is that if we had gone out there and if we had seen a hole in the wing and we knew that it was life-threatening, we would have done something. We wouldn't have sat here and done nothing and wish them bon voyage. So I consider those two parts of your question to be two completely separate things.
Okay, thank you for coming. That's going to be the last question. And we are not doing the table rush. We normally do, so forget about that. And we're going to do some one-on-one interviews with some of the board members in two rooms that are set up in the other room. I've got a schedule for the Admiral, and we'll have some interviews with the other board members as well.
Thank you very much.
Thank you. Thank you very much. Thank you, board. Congratulations, board.
Yes. Graduated here.
I'd like to congratulate the board on its brevity and its clarity.
Layout.
They want their table.